Have you ever wondered why we don't burn ourselves while using a pan? Of course, the handle protects us, but why doesn't it get as hot as the pan? This is due to the handle's high heat capacity as compared to that of the metal pan. Heat capacity is defined as the amount of heat energy required to raise the temperature of a given mass of a substance by 1 unit. Specific heat capacity and molar heat capacity are properties derived from the heat capacity of a material. Heat capacity depends on the amount and size of the substance. Specific heat capacity, however, doesn't vary with the amount of the substance and is therefore a more useful property. Specific heat is defined as the amount of heat required to raise 1 unit of mass of the substance by 1 unit of temperature. In chemistry, molar heat capacity is more useful and is defined as the amount of heat required to raise 1 mole of a substance by 1 Kelvin. Like specific heat, molar heat capacity does not vary with the amount of substance. Determining a substance's heat capacity and subsequently its specific heat and molar heat capacity is not rocket science. The necessary values can be calculated by breaking down their definitions, finding individual quantities, and substituting them in their respective places in the formulas. Specific heat capacity or specific heat can easily be found by dividing a sample's heat capacity by its mass. Another method for determining the specific heat of a substance is by using a calorimeter. A calorimeter consists of the following parts: an inner and outer vessel, stir, thermometer, and insulating material. The inner vessel contains the sample material whose specific heat is to be determined. It is placed in the middle of the outer vessel, which is then filled with water. The procedure starts by noting the mass and initial temperatures of both the water and the sample substance. The sample is then heated. As the temperature of the sample rises above the temperature of the outside water, heat transfer between the two objects begins. After some amount of time, the electric flow is turned off, and the final temperature of the water and the sample are measured. The heat energy lost by the sample material will be equal to the heat gained by the water in the outside vessel. Once the substance's specific heat is found by plugging in the values to the relevant equations, multiplying the specific heat by its molar mass will provide you with the molar heat capacity of the substance. The heat capacity of a substance determines where and when it can be used. For example, the handles of utensils are manufactured from materials with a high heat capacity to ensure the user's safety. On the other hand, thermometers are manufactured from materials with a low specific heat capacity so that they can detect even the smallest temperature fluctuations. The phenomenon of seawater remaining cooler than the surrounding air and sand on a hot summer day, despite being exposed to the same amount of sunlight, can also be explained by the concept of heat capacity. The high heat capacity of water is responsible for many natural events, including the Earth's climate and the survival of aquatic life.